Imagine you're at your desk. You type one simple question into ChatGPT. One sentence. One answer. Done. Feels instant, right? Honestly, how often do you use AI these days? Every day? Multiple times a day? Think about it for a second. When that answer appears on screen, it feels weightless, almost magical, like pulling knowledge from thin air, totally free. But somewhere, in a windowless building far away, a chip starts heating up. Fans begin spinning. Water flows through cooling pipes. Electricity surges through the grid, all triggered by your one tiny question. And on the screen, every prompt has a price. When ChatGPT launched in late 2022, it hit 100 million users in just 2 months. Fastest growing consumer app in history? Most people assumed AI worked like regular software. Build it once, copy it everywhere. The extra cost per user is almost zero. Think about your phone apps. Spotify reaches 100 million users without making 100 million copies of the music. Get it? So people thought AI is basically smart software. Once built, scaling it should be nearly free. The marginal cost collapses, but generative AI is fundamentally different. Every single time you ask it something, it calculates a brand new answer from scratch. Writing an email, generating an image, debugging your code. Every request burns real compute power in real time on real hardware. This isn't software economics, it's closer to factory economics. More users means more electricity, more chips, more infrastructure cost. So the first big question of the AI age was not, how smart can it get? It was, how expensive can this get and who pays? Here's the first twist nobody saw coming. The cost to use AI didn't go up with demand, it collapsed, dramatically and fast. The Stanford AI Index 2025 documents that querying a GPT 3.5 level model fell more than 280 times in just 18 months. 280 times cheaper. If gasoline dropped that fast, filling your tank would cost about 30 cents. Insane, right? Epoch AI found that for specific tasks, achieving GPT-4 level performance dropped anywhere from 9 to 900 times per year in price. 900 times cheaper. In 1 year. That's not a normal price decline. That's the floor falling out from under an entire industry. But here's the strange part. When something becomes dramatically cheaper, people don't always use less of it. Sometimes they use it everywhere. In every app, every workflow, every business process. Scale expands faster than cost drops. This is called the Jevons Paradox. In the 1860s, more efficient steam engines actually caused total coal consumption to explode. More efficiency, more factories, more total coal. Sound familiar? So here's the real question. Is AI making us use less compute or way more? In 2024, something happened in China that shook the global AI industry to its foundation. A price war started, a real one. Alibaba slashed prices on its Tongyi Qian large language models by up to 97%. Not a typo. 97%? Hours later, Baidu announced its Ernie Speed and Ernie Lite models would be completely free for all business users. Zero. ByteDance entered the race with its Dubao model priced 99.3% below the industry average. Tencent. iFlyTech followed within hours. If the biggest tech companies in the world are giving AI away for almost nothing, what does that tell you about where this is going? Then in January 2025, a Chinese startup called DeepSeek released a model that triggered a global stock market sell-off overnight. Its performance was competitive with OpenAI's best models. Its reported training cost was shockingly, almost unbelievably low. In February 2025, DeepSeek cut developer API pricing by up to 75% during off-peak hours. The off-peak window, European and US business hours. DeepSeek didn't just release a model, it released a question aimed directly at Silicon Valley. Can you survive at this price? OpenAI responded with price cuts. Google introduced discounted tiers. The pressure radiated globally, and it was immediate. The first AI race was about whose model was smartest. The second race, the one we're in right now, is about price. Raw, brutal price? So how do you build a world-class AI model and still sell access at a fraction of a cent per query? Let's crack open the engine. DeepSeek v3 has 671 billion total parameters. That sounds enormous, but the trick is, not all of them activate at once. For each token processed, only 37 billion parameters activate. That's the mixture of experts architecture, MOE, in action. Imagine a massive hospital with 500 specialists. But for your appointment, only the 3 relevant doctors show up. Not the whole hospital. You don't run the whole model, you route each query to only the expert layers it needs. That cuts compute costs dramatically. Prompt caching means that if your system repeats the same background context, the model doesn't recalculate it every single time. Model routing sends easy questions to small, cheap models. Only hard problems get the expensive big model. Pay only for what you need. On-device AI means some computation happens right on your phone or laptop. No server, no cloud, no per-query cost to the company. Batch processing groups non-urgent requests together and runs them during off-peak hours when server capacity is cheaper to operate. All of this, MoE, caching, routing, on-device, it's a massive engineering war being fought over fractions of a cent. The stakes are everything. Here's the second twist. Per-query cost is falling, but the total infrastructure bill is exploding. Both things are true simultaneously. Reuters Breaking Views reports just 4 companies, Amazon, Microsoft, Alphabet, Meta, are projected to spend $630 billion on AI in 2026. $630 billion in 1 year from 4 companies. That's more than double the 2023 figure. Let that actually sink in. Goldman Sachs projects roughly $7.6 trillion in cumulative AI infrastructure spending between 2026 and 2031 across the whole ecosystem. Meta is building a data center in El Paso, Texas, targeting 1 gigawatt of capacity, backed by a $13 billion financing package. The IEA project's global data center electricity consumption will more than double by 2030, reaching around 945 terawatt hours. By 2035, Deloitte estimates U.S. AI data center power demand could grow more than 30-fold, from 4 gigawatts in 2024 to 123 gigawatts. Here's the math. AI is cheaper per prompt. Everyone uses it constantly, so globally the total bill is bigger than ever before. Physical bottlenecks are real. Securing a grid connection in major cities like London now takes up to a decade, 10 years to plug in. European transformer lead times have stretched to 100 weeks. U.S. generator delivery takes around 50 weeks. Nearly 60% of projects were delayed. A data center campus budgeted at $1 billion can easily inflate to $1.3 billion or more by the time construction completes. The unit cost of intelligence is falling, but the total demand for intelligence is exploding. Both things happening at the exact same time. A lot of people say Apple is losing the AI race. No frontier model, no viral chatbot, no ChatGPT moment. They call Apple a loser. But wait, if every AI query costs real money to run on a server, and you have 1 billion users, what is your monthly compute bill? Apple's answer is Apple Intelligence. The core strategy: keep computation on the device whenever possible. Don't pay the cloud bill. According to Apple's own documentation, when you make a request, Apple Intelligence first checks if it can be processed on-device. Only complex requests that exceed on-device capability get routed to private cloud compute. Running on Apple Silicon-based servers, Apple Silicon, M-series chips, are optimized for efficiency and privacy. The same architecture in your MacBook runs AI in the cloud. Apple isn't trying to build the world's smartest AI, it's trying to build the world's best cost-controlled AI hardware ecosystem. Different game. While rivals pay massive cloud compute bills per user query, Apple distributes that cost across hardware it already sells at premium margins. Adobe takes a completely different approach to the AI cost problem. Instead of hiding compute costs, it turns them into a product. Adobe calls them generative credits. Every Creative Cloud subscription plan includes a monthly allocation. Use AI features, spend credits, generative fill in Photoshop, generate video in Firefly, translate, and lip sync. Standard features use fewer credits, premium features use more. Notice what Adobe is actually doing here. It's making the cost of AI computation visible and packaging it as a feature, not a hidden tax. If you need more credits, you buy more. Adobe Firefly Standard and Pro plans let users purchase additional credits directly. This is disciplined. Adobe doesn't absorb unlimited AI compute costs on its balance sheet. Users who generate more, pay more. Simple. Apple moves the bill into hardware. Adobe turns it into credits. So, who's really winning the AI cost war? Let's find out. The AI race is no longer just about who builds the smartest model. It's about who controls the physical infrastructure underneath all of it. Think about who wins when every company on Earth spends hundreds of billions annually on AI servers and electricity. Follow the money. GPU and AI chip companies benefit from every model that gets trained or served. Every data center needs them. Demand is insatiable. Cloud providers, AWS, Azure, Google Cloud, rent the compute that AI models run on. More AI demand means more cloud revenue. Always, here's a reframe. In the gold rush, the people who sold pickaxes got rich, regardless of who actually found gold. Sound familiar now? The IEA says U.S. data centers by 2030 will consume more electricity than aluminum, steel, cement, and all other energy-intensive goods combined. Power utilities, cooling system makers, transformer manufacturers. The physical supply chain for AI is overwhelmed and extremely profitable. The real winners of the AI age may not be the flashiest chatbot companies. They may be the boring companies that control chips, power, and cooling. Here's the paradox at the heart of the AI age. AI is becoming cheaper for everyone to use. That part is genuinely real and happening. But the infrastructure that makes AI possible, the chips, the power grids, the data centers, is concentrating into fewer and fewer hands. Access democratizes, infrastructure concentrates. Both movements are happening right now, pulling in opposite directions simultaneously. AI may become cheap for everyone to use, but the machines that produce it may belong to fewer and fewer players over time. Intelligence becomes abundant, but the infrastructure that generates it becomes massive, expensive, and deeply concentrated. That is the paradox. So today's question for you: if AI's price is falling but AI's power is concentrating, who really controls the future of artificial intelligence? That's a wrap for today. The hidden bill of AI isn't just about electricity or money. It's about who owns the infrastructure of intelligence itself.